Okay, so to determine true course, we're going to use our VFR plotter. There's a couple different types of VFR plotters, and determining true course is a little different depending on which type of plotter you're using. So I'll show you how to use this type of plotter first, which has a rotatable card, which makes it a little easier, in my opinion, to determine your true course. Now to do this, you can use any point along your route of flight. It doesn't necessarily have to be from the departure airport, and that's as long as it's a direct route between point A and point B. If you have a change of course, then obviously you'll have to figure out a new course at along each leg. But because this is one straight line from our departure airport to our destination, we can use any point along that route to determine our true course. So why don't we use the other side of the chart where there's a bit of a longer line. Might be easier to determine it that way. So what we're going to go ahead and do is we'll take our VFR plotter and we can align it, align the straight edge portion of it with the course line, which we've done. And now to get the most accurate measurement of true course, I'm going to actually slide this plotter until I am aligned with a line of longitude. So you can see there's a line of longitude right here that goes just to the east of Plummer, right over the town of Brooks. So I'm going to set my plotter so that the straight edge is aligned with the route, and then I'm going to align the card here so that 0 is pointing up. I'm going to slide the plotter slightly so that that 0 line is aligned with that line of longitude. And you can, if you look through the card here, you can see that line is aligned with that line of longitude. So if we make sure that, again, verify that edge is straight along your course line, make sure that 0 line is aligned with that line of longitude. Now you're going to look right here for your true course, and you can see by the arrow, because we're going in this direction, that we would look here for our true course. Do not look on the other side, which would be over here, because that arrow is going this way, which means your true course would be in that direction, which is not the direction that we're going on this particular flight. So let's realign our stuff here. Okay, there we go. So it looks like our true course is, we have 300 here, 310 here, so this would be 305, 306, looks like about 307 degrees for our true course between Brainerd and Grand Forks. So on our navigation log, under TC for true course, I'm going to write 307. Now, because this is a direct route and the course does not change along the route, I'm going to go ahead and fill every box with that course of 307 between each of our checkpoints. Keep in mind the top box in each row represents that true course. The bottom box represents the wind correction angle, which we will determine with our E6B. So we'll do that on our second navigation log as well, between those checkpoints. There we go. Now I'll show you how to come up with that course using another type of plotter as well. So this particular plotter obviously does not have a rotatable card, and obviously it's a bit damaged, so I can't really use it to determine distance, but I can still use it to determine our course. So same idea here, and the line of longitude is essential for this particular plotter. So we are going to, we've got our line of longitude here, and we're going to rest that plotter, the straight edge of the plotter along the route, and there's a grommet, small grommet right here that you want to lay over the line of longitude, which we have now done. So if we look at along that line of longitude, make sure we're all lined up here. So if we look along that line of longitude, that line of longitude continues right through this mark right about here, and there's a couple options, right? It's either 307, this is 305 right here, so this would be 307, or it would be 127. Now, you have to kind of use some common sense here. A course of 127 degrees would be to the southeast, which if we're going from Brainerd to Grand Forks, that would not make sense. We're looking for a northwest course, so therefore 307 would be the correct answer, which we determined with our other plotter, which was perhaps slightly easier to use. Okay, so the next thing that we're going to do, we now have our distances and our true course in our navigation log. Perhaps the next thing that we could use the sectional chart to determine would be our variation. So remember, variation is the difference between true north and magnetic north. Right now we have a true course, and eventually we're going to convert that to a magnetic heading because that's what our HSI uses. So variation can be found on the sectional chart. If we go back to the other side, we can try to find a line of variation. These lines are called isogonic lines, and we see an isogonic line. Isogonic lines are dashed magenta lines. So we've got our departure airport of Brainerd. This dashed magenta line right here is your isogonic line, which is the difference between your true north and magnetic north, or your variation. And you see up here it's labeled 2 degrees east. So our variation on departure out of Brainerd is 2 degrees east. Now, as we go along our route of flight, because this is an east-west flight, if it was a north-south flight, it would not be too much of an issue in this part of the world. But because we're crossing east-west, that variation is likely to change along our route of flight. So if we take a look on the other side of the chart, we have an additional isogonic line, which is now for 3 degrees of variation, and that's over by Monoman. And then as we approach Grand Forks, just to the west of Grand Forks is another isogonic line, which would represent 4 degrees of variation, which you can't see. Yep, there we go. The number's right down here, 4 degrees east. So we're going to cross 3 isogonic lines, or come very close to 3 isogonic lines. So on our navigation log, departing out of Brainerd, our initial variation was 2 degrees east. Now you'll notice that east is marked with a minus sign, because you would subtract that variation to convert from a true heading to a magnetic heading. So the top box here is going to represent true heading, which we don't know yet. The bottom box is going to represent the variation. So variation is -2 after departure from Brainerd, and it'll be that way for a little while until we start to approach Monoman. So we'll go ahead and put that in there. So we got 4 checkpoints there. Maybe we'll use 2 degrees once more. And now I say we will let's transition to that 3 degrees of variation as we get closer to Monoman. There's Monoman right there. And then as we approach Grand Forks, we will now be closer to that 4 degrees of variation. So we've now got that change in variation is now plotted and indicated on our navigation log. And now we are pretty much done with the sectional chart, at least for the time being, until we calculate all of our times, our speed, our heading, and our fuel burn using V6B.